Well, good morning, everyone. I am really sorry that this is the first lesson that I'm actually getting to teach this year and that I'm not here. We do have a golf match today in Cookeville. Most of the time, our matches are in the afternoon, and I won't actually have to miss the whole day, but this one happens to be a tournament, and we won't be here all day. In fact, we have to be in Cookeville by 7:45. So, um, again, I hated that this was the first day that I'm actually teaching a lesson. So hopefully you guys will do just fine watching this video. Again, I have to miss sometimes for golf. I have to miss sometimes for, my athletics position. So there will be times where you'll have to learn this way. But just always remember this, okay, before we get started. If you struggle, I promise you, tomorrow when I come in, I will make sure that nothing was tricky and that you're clear on how to do everything. So when I come in tomorrow, again, we'll go through this. And if you struggled with something, I will make sure and clean it up. I won't just move along on a day like today when I wasn't here with you. I'll make sure that you're in good shape before we move along, okay? So today, we're actually talking about solving equations, and this is really just a review. In fact, if you guys recall on Friday last week, we did look at that error analysis, and we talked about how it's really easy to see when other people make mistakes, but a lot of times when I'm just solving a problem on my own and I get to going real fast, I sometimes make mistakes, and we want to try to avoid making as many mistakes as possible. So what I want you guys to do is just take your time on these. We're going to work through some of them together, and then some of them will be what I expect you guys to do tonight. So you might see something on a homework assignment that might be just a touch different than one that we're doing in class, but it would be very slightly different, not big time different. So we're going to go ahead and kind of work through the left side. But before we do that, this is really what it's about. When we solve equations, it's basically four steps, and sometimes you don't have to even follow all four of these steps because they don't have these steps, or sometimes there's something you can do instead of one of these steps. It might just be a touch different, which I'll talk about as we look at some problems together. But here are the steps of solving. One, you want to use your distributive property. If there's ever a situation like we have here on number one, where you have a number 6 outside these parentheses, the first thing we want to do most of the time is distribute. Now, I say that because sometimes, and again, sometimes, not always, sometimes it would be better for us, instead of distributing it to this n plus 5, dividing it and moving it over to the other side. See, that's multiplication. So technically, I could divide. Now, why won't I do that on this problem? Well, because I'm immediately going to work with fractions, and generally, people don't really love fractions, and we try to avoid them at all costs. So you could do that, but we're going to go ahead this time, and we're going to distribute. So here we go. We're going to go 6 times in, 6 in, and then again, don't forget, you want to distribute 6 to both terms that are inside here. So 6 times in, yes, but also, what's 6 times positive 5? Positive 30. And that, of course, equals 2. So if there's distributive property in the problem, then go ahead and do it, okay? Start simplifying this problem by using distributive property. Now, step 2, you can see here, it says simplify each side. So if you were to take this and try to picture it as like it's a barrier wall, right? This barrier wall is where that equal sign is, and I'm just looking at the left side here. Is there anything on this left side that I can combine? Because that's what step 2 is about. We want to simplify this left side. Is there like terms that I can get together? And if there are, I get them together exactly the way I see them. Well, 6n and 30 cannot be combined because one has an n, one doesn't. Same on this right side. 2 is all by itself, so there is no step 2 in this problem, okay? Now, step 3, it says move variables to one side. So again, if I had this barrier wall and I had variables on the left and the right, I want to get them on the same side. That's going to be my third step. Well, again, y'all see this 6 in here. That's the only variable term. So there's no step 3 here either. So now we finally get to step 4, and that is you get to solve. Okay, solve the problem. So you're going to use, like it says, inverse operations. But there's a little bit more to it than that. Because see, if you look at this particular problem, I'm trying to get n right here. I'm trying to get that alone. See, there's a 6 that's multiplying by n, and then there's a 30 that's being added to 6n. So not only do I have to do inverse operations to move these things, I have to move them in the correct order. For example, that 6, that's really close to n. I can't move that before I get rid of this positive 30. So the first thing we're going to do is we're going to subtract this 30 to the other side, and then that's going to leave us with 6n equals, and 2 minus 30 is negative 28. See, now I can move this 6, which again, like I said a minute ago, it's multiplying by n. So the opposite of multiplying is to divide by 6. Now, I hope that you guys grabbed your calculator as you were walking in. You see that list. If you forgot what number you are, you're on there. So one or two of you at a time, if you didn't grab a calculator, start moseying over there. But you have a number here. Negative 28 will not divide evenly by 6. So I want to show you this problem because I'm okay with you writing them in several different ways. Okay, one, if you were to use your alpha y equal key on your calculator is really good about simplifying fractions. So if you use alpha y equal and then you plug in negative 28 over 6, it will shoot it back out to you as negative 14 over 3. And that's a great answer. Now, after you've done that, I want you to try this too, okay? I want you to hit alpha y equals again, but then I want you to utilize the function that will take it from an improper fraction to a mixed fraction. I want you to try to find that on your own. Take it from an improper fraction to a mixed fraction. If you can't do that on your own, maybe your neighbor can show you. And if neither of you guys can figure out, I'll show you tomorrow. But if you use the alpha y equal keys, you can change this to what we call a mixed fraction, and the answer is also negative 4 2/3. That one's great too. That one's great too. Now, most of the time, I say that if you're going to round it to a decimal, you can do that too. You can also do that in alpha y equals. Again, it's the very bottom. You'll see it. But I also don't mind if you were to round this to negative 4.67. Usually, if we're rounding, I would say let's go to 2 decimals. But I just want you guys to notice, every single one of these answers would be fine. Negative 14 over 3, negative 4 2/3, negative 4.67, all completely fine, okay, as far as answers go. So there you go. That's how we solve equations. Now, most of you guys are probably looking at that like, that was a breeze. Well, good. If that's a breeze, then you're gonna do really well as we move into some of our topics this year, because that's going to be a skill that just has to be known by you, how to solve equations. You got to know. So let's go to number 3. Let's just tick through our list, okay? Number 1, distributed property. Do you see it? You sure do, right here. This 2 needs to be distributed. So here we go. Ready? 2 times 2, 4. And 2 times negative 7y. Remember, 2 times negative 7 is negative, so minus 14y. And then bring down everything else. Minus 5 equals 111. Now, clearly, I have no more distributed property. So look back at our rules. simplify each side. Again, try to imagine there's a barrier wall right here. Is there anything on this left side that you can just get them together? I hope you see it. You can get 4 minus 5 together. See? Same side, you just combine them. Well, 4 minus 5 is negative 1. 4 minus 5 is negative 1. And then you're going to bring down that minus 14y equals 111. And let me erase that. There's nothing else on this side we can combine. Look, negative 1 doesn't have a variable. Negative 14 does. You can't put them together. So let's look at step 3. Step 3 says move variables to one side. Again, I see a variable here, this y, but I don't see it anywhere else. So again, no step 3 needed. So that finally leads us down to the very last step, step 4, and that is solve. Get y alone. Well, look, negative 14 is right next to it. Hold off on that one. But this minus 1, I got to move it, okay? So if that's a minus 1, it's subtracting 1. It's negative 1. Look, negative 1 is not multiplying by y. It's just being combined to negative 14y, and it's negative. So we're going to get rid of it by adding 1. Okay, that will allow it to cancel. Negative 14y will come on down. And 111 plus 1 is 112. Now, again, be careful. We want to now get rid of that negative 14. Please don't go, well, I got to add 14. No. Look, negative 14 is doing what when it's jammed right next to y? It's being multiplied, right? So what's the opposite of multiplication? Well, we're going to divide. We're going to divide by negative 14. So if you type it into your calculator, 112 divided by negative 14 actually works out nice, and your answer is negative 8. And there you have it. There's your answer. Y equals negative 8. Okay? Moving along, let's just go directly below. And let's just start knocking through these. And again, this should be something that at the end of this lesson, at the end of this video, you should know when you look at this, your process. 1, distributive property. Do I have anything that needs to be distributed? I see no parentheses. If there's no parentheses, there's nothing needing to be distributed. So we move to step 2. Look at the left side of that equal sign. 10a minus 7. Can I get those together? Nope. Look at this right side. 21 minus 6a. Can I get those together? Nope. So there's no step 1. There's no step 2. So we go to step 3. There's step 3. Look, there's a 10a here, and there's a negative 6a here. Remember, step 3 was, and we haven't done it yet, move variables to one side. So let me just tell you what I like to do. I always like to move the smaller variable. Here's why. If I move the smaller variable, I'll always be working with a positive coefficient of whatever my variable is. If it's a, if it's x, whatever. The coefficient will always be positive if I move my smaller variable. So which one's smaller, y'all? Is 10 smaller or is negative 6 smaller? Well, definitely it's negative 6. So we're going to move that whole thing past equals, so we do opposite operation, right? Inverse operation. We're going to add that 6a to 10a. So 10a plus 6a is 16a. We bring down the minus 7 equals 21. And those 6a's and negative 6, those things cancel each other out. So we got our variables on one side. Now, sometimes people just live by the rule, always get your variable to the left side. And you don't have to do that. But if you just love that, then okay, I'm not going to stop you. But anyways, now we're ready to step 4 for step 4. And step 4, remember, is we want to get that variable alone. Now, after doing 2 of these problems, y'all should be in pretty good shape right now. Like, what do I need to move away from the a first? The 16 or the minus 7? Well, remember, 16 is right next to it. Not that. Let's move the minus 7 first. You have to. It's not like, well, this time I want to move. No, you have to move this minus 7 first. And you do that by doing the opposite. You add it. Those will cancel, and 16a will equal 21 plus 7, 28. Now, I think you guys probably know 28 is not perfectly divisible by 16. So I would encourage you to go to alpha, y equals, and do 28 over 16. You would get 7 over 4. Or you could change it to a mixed fraction, 1 3/4. Or you could change it to a decimal, which happens to be a really nice one, 1.75. I will accept every single one of those, okay? I'm not going to be overly picky about which one you guys use, okay? They're all correct. Moving on. Number 7. Hopefully you're keeping up. Okay, here we go. We're going to go a little faster. Distributed property, step 1. Oh, yep, there we have it. -5 needs to be distributed. Here we go. What's -5 times 8p? -40p. What's -5 times +6? -30. And that equals 5 minus 5p. Okay, now look at the left side. Any like terms? Nope, that has a p, that doesn't. Look at the right side. Any like terms? Nope, that has no variable. This has a p. So I can't simplify either side. Step 3. Let's get our variables on the same side. Well, which one's smaller, y'all? -40p or -5p? Well, definitely -40p. So that's the one I'm going to move. I'm going to move it by adding 40p. Okay? So it'll cancel on the left. So -30 drops down. On the right side, 5 drops down. But what is -5p plus 40? And I think I asked you that the wrong direction. Whenever I have a negative and a positive, I always like to say the positives first. Listen, which one makes more sense to you guys? What is -5p plus 40? Or what is 40p minus 5p? See how that just makes more sense, doing the positives first? 40 minus 5 is 35, so positive 35p. All right, so step 2 is done. Step 3 is done. So now we're ready for step 4, the last one. Let's get that p alone. Well, I know I'm not moving the 35 yet, so I need to move this positive 5, and I do it by subtracting 5. So over here on the left side, -30 minus 5 is -35. On the right side, again, remember these cancel, so 35p drops down. So how do we break 35 away from p if it's being multiplied? We divide by 35. And if I divide by 35, -35 divided by +35 is -1. So p equals -1. Done. All right, hope you guys are just rolling right along. Let's go to the back side and let's look at a couple of different problems. This one looks a little bit tricky. I'm going to kill 2 birds with 1 stone. Hope you can bear with me, because remember, step 1 is distribute, and I have some distributed property going on, don't I? Right here. So I'm going to go ahead and go -3 equals, what is 9 times 5? 45. And what's 9 times -2k? Well, that's -18k. And that is divided by 5. Now listen, I know that there's a fraction bar here. But remember, when I have a fraction bar, I'm simply dividing by 5. So here's the point. If I want to get rid of that, what's the opposite of dividing by 5? We want to multiply both sides by 5. So on the left side, we have 5 times -3. That's -15. On the right side, this 5 in the denominator and this 5 in the numerator, it's like they just cancel, okay? That's what happens with inverse operations. So 45 minus 18K comes on down. Okay? So that's not too bad. And now all of a sudden, we're at step 4. See, there's nothing to combine on this left side, nothing to combine on the right side. We only have one variable left. So now we just want to get that variable alone. Step 4. So we're going to do that by moving the 45. Subtract it. Subtract 45 from negative 15. So here we go. What's negative 15 minus 45? Well, that's negative 60. And what's that equal? Well, don't forget this negative comes down with it. So negative 18K. Now, last step, again, still trying to get K alone. Remember, I know that's a negative, but we're not adding 18. Negative 18 is doing what to K? Multiplying. So we divide by negative 18. So negative 60 divided by negative 18 ends up becoming a positive answer. And here are your different possibilities. You could have gotten the improper fraction 10 over 3. Or you could have got the mixed fraction 3 1/3. Or you could have gotten the decimal answer, which would have rounded to 3.33. Every single one of those are right, but let me just say, you don't have to write every one of them. I'm writing them all because I want you guys to know that they're all fine. But you pick which one you want to do. Do you want to do an improper fraction? Do you want to do a mixed fraction? Or do you want to write it as a decimal? I'm not going to be real picky, okay? It's your call. Your call. Okay, you'll see this word out to the left. It says special cases. So let me show you why this is a special case. It's not the way that you solve this problem that makes it special. It's what happens when you solve it that makes it special. Let me explain. Watch this problem, okay? First of all, do we have distributive property? Yes. Now, if you look at this left side, 1 plus 3c, you can't do anything with that. But over here, let's distribute. What is 5 times 1? 5. What's 5 times negative c? That's negative 5c. And then don't forget to bring down this plus 8c. Now, after doing that step, I want you to notice, we do have some like terms on this right side that we can put together. And remember, when they're on the same side, you combine them exactly the way you see them. So look at what I'm left with. I'm left with 1 plus 3c equals 5 comes down. But what is negative 5c plus 8c? Or remember what I said? I like to do the positive one first. What's positive 8c minus 5c? That's positive 3c. So we've taken care of step 2. Let's move to step 3. Step 3 is getting our variables together. And this is where something weird happens. Remember I told you that I always like to move the small one? Well, we got a positive 3c and we got a positive 3c. They're both identical. So it really doesn't matter which one you move. Here's what happens. When I subtract 3c from both sides, it'll cancel each other out here, but it also cancels on that side too. So you have no variable left over. All you have left over is 1 equals 5. Now, is that true? Does 1 equal 5? No, that's not true. So this is why this is called a special case. If your variable cancels, there are going to be 2 options. So when your variable cancels, here are your 2 options. If the numbers are equal, then our answer is all real numbers. That means everything would work. Everything would be your correct answer. But if they don't, if the numbers are not equal, does anybody remember what this is called? If you said it, it's no solution. No solution. So if you look at number 11, look, 1 and 5, those are not equal. So here was a case where our variable canceled and the numbers are not equal. So you would have to say this problem has no solution. What does that mean? It means that there's literally no number in the world that I could plug into C and make this equation right here true. Nothing in the world would work. The other one, when the answer is all real numbers, it means that every number works. So that is why this is called a special case. Now, you're going to see number 12 when you do it on your own, and it might look a little different. We'll see. Okay, got a couple more. First, proportions. Remember, when you have two fractions that are set equal, you can make life easier by simply cross multiplying. Do y'all remember that? Cross multiplying? So we're going to take 5 and multiply it by x plus 4. Now remember, that's just like going 5 times x plus 4. It's like distributive property, right? So I've got to remember to do distributive property. So let's do it. What is 5 times x? 5x. What is 5 times positive 4? Positive 20. Equals, because now we're going to do this other. So what's 3 times 2? That's 6. So there you have it. Okay, now we've got just a simple problem to solve where we need to get x right here alone. So what are we going to get rid of first? Well, definitely the 20. So I subtract 20. So 5x will equal negative 14. And then last, we're going to divide by 5. And again, I'm not too concerned how you leave these answers, but here are your options. If you left them as an improper fraction, negative 14 over 15 or negative 15 over 4 actually won't reduce. So that'd be your improper fraction. Or negative 2 and 4/5 would be your what? If you said mixed fraction, you're right. Or if you wrote it as a decimal, it's negative 2.8. So all three of those are beautiful answers that I would accept without question. So you pick. I'm not going to be picky, so you pick. Okay, now the last couple problems really throw people for a loop sometimes because you're solving an equation, but a lot of times when we start solving equations, we think, oh, I got to come up with an answer. And we're always expecting like the answer to be x equals 7 or x equals negative 13 or a equals negative 5 over 3. But sometimes, you guys, your answer when you solve an equation is another equation. Let me explain. Look at 15. We're trying to solve for pi. We're trying to get pi alone. But you see, what's with pi? 2 and r all jammed there with it means that this is 2 times pi times r. Y'all are probably familiar with this formula for circumference. But 2 and r are both multiplying by pi. So if I want to get pi alone, what would I have to do? Well, I would have to divide by 2r. Right? That's how I would get it alone. So I would divide circumference by 2r. So literally, guys, that would cause the 2 to cancel, the r to cancel, and sure enough, I will have solved this problem for pi. So what is the solution for pi? Circumference divided by 2 times the radius. That's the equation for pi all the time. Circumference divided by 2 times the radius. So sometimes you solve an equation just to get another equation. So again, maybe you're like, oh, that's easy. Great, because sometimes people really struggle with that. Let's look at 2 more problems, and then again, same concept. Here we're solving for b. So right here's b. Now again, look, we're trying to get b alone. What do we got? Well, we got a up here with it, and it's being divided by c. Now look, because A is up top with it, it's closest to it. So the first thing we need to do is we need to get rid of the C. So what's happening with the C? Well, it's being divided by C, right? It's being divided by C. What's the opposite of dividing by C? Well, we want to multiply by C, right? We want to multiply both sides by C. Sure enough, these will cancel, and that'll leave me with A plus B equals, and on the other side, 5 is being multiplied by C. Now, again, don't lose track on what we're trying to accomplish. We're trying to solve for B. We're almost there. We got rid of the C. Now we just need to get rid of the A. Well, how do I move positive A? By subtracting. We're going to subtract A to the other side. Now again, don't let this mess with your mind. I can't combine 5C minus A. I'm not getting an answer. I'm not getting B equals 13. Okay, I'm getting B equals 5C minus A. We solved an equation just to get another equation. And sometimes people just don't like that. But that's how it works, okay? Last problem. This one's pretty tough. Hopefully you're going to see this. We're going to talk about some more of these problems for sure. But we're trying to solve this time for V. V. Now, I know that we've talked in the past about distributing. But if I distribute this 1/2 to W plus V, it's probably just going to make things a little bit more complicated. Remember, 1/2 times W plus V. But here is a trick. I never want to do the opposite of multiplying with a fraction. I never want to divide by a fraction. No, no, no. We don't want to divide by a fraction if we can keep from it. Does anybody know what we like to do instead of dividing by a fraction? Okay? We're not dividing by fractions in this class, as long as we can keep from it when there's variables involved. Instead of dividing by fractions, we're going to multiply, anybody get it? By the reciprocal. I hope that some of you guys actually remember that. We don't want to divide by fractions. Instead, we want to multiply by the reciprocal. See, look, 1/2 is multiplying by W plus V. But instead of dividing by 1/2, which we don't like, we're going to multiply by the reciprocal of 1/2. Well, look at there. What is the reciprocal of 1/2? 2 over 1, or 2. We're going to multiply by 2. So look at the other side. What is 2 times 7W? That's 14W. And then here, the 1/2 and the 2 cancel because we multiply. Look, it'd be like 1 times 2 is 2, 2 times 1 is 2, so 2 over 2 is 1. So it's like it just disappears. And we're left with W plus V. Now don't forget, we're trying to get V alone. So do I need to move this W? So subtract W. Remember, isn't this understood to be a 1W? Absolutely it is. So what is, final answer, 14W minus 1W? So 13W equals V. Again, we solved an equation just to get another equation. So if you haven't recognized it up to this point, your assignment is to do the right side of this worksheet. That leaves you with 10 problems. 2, 4, 6, 8, 10, 12, 14, 16, 18, and 20. Okay, I think that's 3, 4, 5, 6, 7, 8, 9, 10 problems. So tomorrow, like I said, when we come in, if you had any questions over the problems that I worked on the left side, I'll go back and revisit those. But also tomorrow, I will make sure, after we look at your homework, that if you had any real questions or real concerns, I will make sure you're good to go on how to solve these different types of equations, okay? That was about a 35-minute video. good luck. You got about 10 minutes, and I'll see you tomorrow.